couple more examples here of solving a rational equation for a specified variable. So in this example, we have 1 over p plus 1 over q equal to 1 over f. And we're asked to solve this for p. Okay, and p is in a denominator. So the first thing you want to do on any of these, multiply by the LCD, which in this case is just FPQ, right? And when we do that, again, I'm going to write that somewhat optional step. FPQ over P plus FPQ over Q, right? You have to distribute this to each numerator. Equal to, what's this going to be on the right-hand side? The F's will cancel, right? And we'll end up with PQ. All right, so over here, P's go away, Q's go away. We have FQ plus FP equal to PQ. Okay, so we got rid of the fractions, and some of you may say, okay, well, how does that help us? We now have two terms that have a p in it, right? And we're trying to get p by itself. So let's get p on one side of the equation. So I'm going to subtract fp from both sides. So what I'm doing here is I'm getting everything that has a p in it on one side of the equation, right? So I have fq equal to pq minus fp. Okay. Now, if we didn't have so many variables involved, right, like it would make more sense to you getting everything with a p on one side, and we would combine like terms there and then divide by whatever p was being multiplied by, right? So in this case with the variables, it's not quite so obvious, but on the right-hand side there, p is common to both of those terms, so factor it out. I'm going to factor out a p. And now I do have p times something, right? So I'm going to divide by that q minus f, right? What p is being multiplied by there. Okay, so that goes away. Okay, so we'll end up with fq divided by q minus f equal to p. Okay, so whenever you're solving a rational equation for a specified variable, multiply both sides by the LCD and then do whatever algebra you need to do to get to the variable that you're looking for to get that on one side. All right, so one more example here. We've got big E over little e equal to big R plus little r all over big R. And we're trying to solve this for big R. Okay, so I look at the denominators and I'm going to say, okay, well, my LCD is big R little e, right? Big R little e. Okay, so on the left, e will cancel, and I'm left with big R big E. And on the right, r's will cancel, right? And I'm left with big R plus little r times little e. Okay. Now I'm going to distribute little e through on the right hand side. So I'll have big R big E equal to big R little e plus little r little e. Okay, now keep your eye on the ball here. We have cleared the fraction and now we're trying to solve for big R, right? Okay, so we have two terms with big R in them and I'm going to get them on one side of the equation. So to do that, I'm going to subtract big R little e from both sides, right? So I'm going to pull big R little e over to the left-hand side of the equation. Okay, so I have big R big E minus big R little e equal to little r little e. Okay, now on the left-hand side, both of those terms have the big R that we're looking for. Factor it out. So we're going to have big R times big E minus little e equal to little r little e. Okay, and now I have R times that quantity of big E minus little e. So I'm going to divide both sides by that. So big R equal to little r little e over big E minus little e. Okay, so again, same concept here. We multiplied both sides by the LCD, and then from there we're doing all the algebra that we need to do to get the variable that we're wanting by itself.